Hello, hello, live now. Let me just tweet about this and we can get back to our stream. Okay, so today's plan was today's plan is to learn about nil. Let me open the video uh, docs. It's nil dot foundation and documentation. So you can we can start from here only. So nil is a sharded blockchain that resolves Ethereum scalability issue via sharding. So if you don't know what sharding is, then let's understand like what that is. Right now, all of the where is the browser window? Yeah, all of the block EVM chains are not like sharded, where they are single core. Single execution happens on a single core, which reduces the TPS that they can produce or they can output. Where is this dark? Okay, so let's assume this is an EVM and this is a single core. There can be multiple on EVM. There will be multiple core every context. So this is, let's say this is an execution core, and then this is what can we say? This is like monitoring, monitoring. Okay, so I don't know if all the thread cores are used in the EVM, but I do know what I do know is core 1, core 2, core 3. So what I do know is execution happens on only one thread, where you have to you actually have to execute transaction one by one. Not you, but the VM. So transaction one, then we can say transaction two, and transaction three, and transaction four. And this would have been a good idea. Like, this would have been a solution that someone would have implemented when there were not enough cores. Like at the start, when Ethereum started, I don't know in 2015, like what was the max core count a computer can have, or a general purpose computer uh, had in 2015. But this serial execution of transaction is not that great, because you have to wait for this transaction to complete, then this, then this, then this. But if you see any regular laptop or even mobile, you don't see a single core machine. Like no one will do a single core machine. Even if you see like a Raspberry Pi, Number of cores. There are 4 cores. So Raspberry Pi has a 4 core machine, and if you're only using a single core, that's not great, right? Because you are losing the performance on rest three that are remaining. So if you do in this way, you are just putting these things on side and not using the machine to 100% performance. So the idea for this is, let's say, EVM. Idea for nil is, I'm just telling you what I understand. Is not exactly, it might not be same. There are parallels, so keep that in mind. Let's put, there is a 4 core machine, core 4, and you see this. So all the things will have, all the cores will process transaction parallelly in a single machine. So sharded, shard, sharded EVM. What it will do is, if this is our like RPC endpoint. All the transactions are coming through here. Then what it does is, it gives some to core 1, then it gives some to core 2, core 3, and then core 4. Before, what was happening, like we had this thing at the top, and everything was going from here to here. So you see, if a single core can handle 4 4 cores will handle 16. So that's the performance boost you'll get, right? There are some issues here where, just a second. Yeah, so if what why like single core execution is there in EVM? It's simpler, it's easy to implement, and you don't have to worry about anything else. But here, in in a VM that has like that is sharded and processing all the transaction on all these 4 cores, what do you think what will happen? So main thing is, here in regular EVM, if transaction 1 changes some state that transaction 3 has to access, it will happen one by one, right? But here, if core 1 transaction 1 changes some state and core 3 transaction 4 needs to know like what is happening, or it's changing the same state, there might be some conflict here in core 1 transaction 1 and core 3 transaction 4. So these kind of issues come into picture when you put try to process transactions on these like different cores instead of single one. But we don't really need to worry about it how this is happening, because the engineers at Nil Foundation or whoever is working on these kind of sharded EVM, they already thought of that, and they we have to change our contracts accordingly to adjust for this. So EVM, it's straightforward. We know what we are doing here. There are some differences that we need to understand while working with this. So we will understand those. But for now, just keep in mind like these sharded VMs will have a different kind of flow compared to regular EVMs. Similar on core one, all the transactions that are coming in, the node needs to check like core 2, core 3, core 4 transactions are not dependent on these transactions or not changing the same state. So these kind of minor things, not minor, but these kind of changes, this this thing does, these VMs do, where they need to understand like, uh, okay, this transaction will change state for these contracts, and next transaction will change state for this contract. So maybe we need to push these two on one core and others on other core. So these kind of minor things you need to think about when you are doing the VM. But for us, it's they will document what we want, what we need to do, and we just have to follow the guide. So okay, Nil is we'll just go through one by one, and there are a lot of things here. L- like the wallet is not the same. There are some differences. Then tokens, these tokens and multi-currency support. So this kind of thing is you need to understand why they are doing this and not going with like a regular ERC20. Like there is there a why they are not creating ERC20 and why they are creating this separate. Hello, hello, hello. Okay, sorry. I was adjusting my mic gain. Hopefully, it's not too loud. Too loud. Okay, now it's pretty. It's in the range. Okay, I was saying these tokens. You can do ERC20, regular ERC20, but there are some differences that you need to consider, and that's why they created these different kind of tokens. So let's just go through everything here, and we can go step by step, one, two, three, four, and then cookbook. Cookbook has multiple tutorials that we can follow and create this thing. Also, this we are going to use hard hat here. So hard hat and JavaScript. So I'm not very good with that right now, and maybe I'll use ChatGPT support for it. I'm very I'm great with Solidity, but I haven't done I haven't like worked on any project with JavaScript in a while. So I need to brush up on those skills. If I'm taking some breaks or not talking for a few minutes, maybe I'm googling something about that thing. So just keep that in mind. Okay, what's next? Cookbook? No, not cook. Documentation. Yeah. Nil is Ethereum layer 2 blockchain powered by ZkSharding. The cluster the cluster unlocks the power of many machines by partitioning state across shards, with cross-shard communication being a built-in feature of the protocol. I don't know what cluster is because this came out of nowhere, but I do know what they're talking about shards and partitioning state across shards and so here this this one core will be one shard and it will have its own state. This will have its own state. So that's my assumption. And when you want to call a contract from shard 1, no, when you want to call, when a contract from shard 1 wants to call contract on shard 2, they need to do a cross shard communication, like a call that is cross shard. So this this core talking with this core, that's what they need to do, and that's built in. So that's what they're saying, like cross shard communication being a built in feature. Okay. Design of nil embodies three core qualities: horizontal scalability, state partition across execution shards without state and liquidity fragmentation. Modularity. Nil acts as a execution layer while using Ethereum for data availability and consensus. So this is basically a roll-up concept. If you don't know roll-ups or haven't learned about roll-ups, you need to brush up on this kind of thing. What is data availability and what is consensus is general blockchain thing, but data availability is like more vocal in layer 2s. In layer 1 that concept is there, but we don't have to think about it. And layer 2s developers have to think about it. Okay. Verifiable security. The entire null network can be verified with single zero knowledge proof attesting to correctness of all shards. Design of nil transcends the typical monolith versus blockchain discourse as it emphasizes horizontal scalability above all. Nil scales nil scales out beyond the constraints of single machines processing power by leveraging ZK sharding, a new type of sharding architecture. In ZK sharding, message processing is delegated to execution shard, which contain small partitions of overall state. Execution shards are managed by main shard while a special sync community handles data availability. Sync community is responsible for producing ZK zero knowledge proof, verifying intra-shard state transitions. So there is a main shard and there are like child shards. Main is handling like shards, all the child shards, and child in this it's like execution shards. So there is one controller and then there are operators. Controller does everything. Controller tells operator to do everything. Controller operator. Okay, maybe I'm using terms wrong, but you understand the thing, right? So in our this, we need to modify this. Let me, yes. Okay, we have this. Let's move this down. is this, and there will be this one shard, main shard, execution shard, copy. So that's what they're telling, where one, all the transactions come in here, hopefully, and then they move on to, they are sent to rest of the execution shards. Okay. In addition, cross shard communication are incorporated directly into nil protocol. This means that issue of state fragmentation is avoided entirely, as each shard can call contracts deployed on different shards. So yeah, one shard talks to another. That way, even transactions that need like data from different shards can access it. That's the base gist of that idea. In nil, it is only possible to deploy smart contract on execution shard. The main shard exists for synchronization purposes only. Understood. Nil offers an effective strategy for scaling Ethereum while avoiding limitations typically associated with modular approach such as state and liquidity fragmentation. Okay, we already have discussed this. So why they have this token standard is for this problem, liquidity fragmentation. Key differences with Ethereum. Following table summarizes how nil differs from Ethereum. State nil, state partition between the individual shards responsible for message execution. Okay, state is not partitioned. Execution support of async message execution, only sync message execution accounts. All all accounts are smart contracts, no EOS. Separation of EOS and contract accounts. So this is basically, there is no EOA means you can have any logic for your wallet. You can have multiple calls executed at one time, or whatever you want basically. Deployment support of internal and external deployments without requiring an EOA. EOA or a smart contract are required for deployment. So I don't know what is internal deployment and external deployment is. Maybe this is particular to nil, but yeah, I only understood we don't require EOA we don't require EOA for deploying the contract, and on Ethereum we do. RPC custom loosely modeled after custom RPC loosely modeled after the Ethereum RPC, the original Ethereum RPC. So yeah, this point is not needed. I am not sure why they have added this. You, their whole structure is different, so RPC will be different too, right? They want to be Nel wants to be EVM compatible, or they want to support Solidity and all the existing infra that EVM has, but because of this cross chart communication and all, uh, method names might be same, but method parameters will be different most of the time. So RPC, I'm pretty sure it was gonna be different for uh, nil because it's different from Ethereum. That's the only reason. Currency and token. One native token used to pay for execution. Contract can create contract contracts can create and be debited in custom currencies. One native token support of multiple token standard. I don't understand contract can create and be debited in custom currencies. Will when we go to this point, token and multi currency support will understand this. Okay, architecture, work in provision, work in progress provisions. The material in this section may describe features and components that are not yet part of cluster as it is available for developer. Okay, so documentation is lagging behind the development. Yeah, that's mm, that will happen for most of the projects. So cool. Just a second. Okay, prerequisites. This de page this page details this page details the steps that need to be completed before working with null dependencies. Prior to working with null, it is recommended to install following. Okay, Node.js 18 and above we have, npm we have, git we have, hard hat we don't need to have that. When we clone a project or create a hard hat project, it'll work. This will allow for using entire set of developer tools provided with null, such as null client library and null hard hat plugin. Install Node.js and npm via okay, just commands to install those. I don't know what this will do. Like, does this installs globally, or it just creates a new project? No, Mac directory null intro. Now we can open that folder, null intro. Hopefully it's already, yeah, it just installs it here locally. We don't know, we don't need this. Browser nil nil smart contracts package. The nil foundation smart contracts npm package contains the source code of all extension libraries and various Solidity contracts used inside null, such as basic wallet contract. Okay, can we find the GitHub repo? Let's go here and any other. Yes, we have GitHub nil.js contracts. We can search on. No, that's not the. It is a smart contracts. Readme packet.json. What's in the readme? Okay, then why is the name of the thing different? Name of the repo. I'm not sure if that repo is it public or no? When was this updated? Five days ago. Okay, we'll find that repo somewhere. It's not like it won't be hidden for long. So okay, let's go to next. Follow this example to learn more about theory behind async execution and complete this tutorial for handling. Okay, where do we go? Core concepts. Okay, we'll read core concepts after this. Prerequisite. This part is done. JSON RPC. Null exposes JSON RPC API that supports several methods from regular Ethereum as well as some methods that are unique to cluster. So, as I said, they will have some methods similar but not all because it's unique in a structure. Apart from usual means of interacting with JSON RPC like sending curl request, documentation portal provides an interactive API session. It's like interactive API reference. To use for to use it, follow the link above. Select a method. To use it, select okay. Input API endpoint from in the form and fill the method parameters. Click on send request to send a request. Okay. Portal will also generate valid curl script depending on the request parameters. The script can be used in CI/CD pipeline or bash scripts. Okay. Are we doing something wrong? Interactive API. Interactive API. I did that. Okay. Is the wrong? I think it should be nil references JSON RPC API, but they have nil reference client. Okay, probably I'll send a PR for this, but now we can see here username token shard ID block and then full transaction full TX, and it will send a request and result will return all these things. Also for this, I think that there is a Telegram bot that they created. Let me check once. Okay, just a second. Huh? I'm just trying to find. Yeah, nil. The name of the bot is nil devnet token bot, and give that will give you the URL. Yeah, that will give you the URL. So I'll put. Not sure if I should put or not, but nil devnet token bot. That's the name. Keep that in mind. Back to our prerequisites endpoint CLI. We did the JSON RPC API. Now CLI. CLI is an easy to use tool for interacting with cluster from any shell. It supports all major operations and can be integrated with CI/CD pipelines. CLI is distributed as a standalone binary to install. Okay. Initial setup is required for nil CLI to be able to interact with cluster. Okay, when we reach that point, we'll learn config. We need to set the config, create a private key, create a wallet. Okay, four steps, four simple steps. Next is okay. While using the CLI, it is possible to switch between verbose and quiet outputs using dash dash quiet dash q and dash dash verbose dash v flags. This documentation uses verbose outputs throughout. Okay, client library. This will be to interact with it. Okay, we don't need to read that because I'm not interested in that particular section. I want to actually work on smart contracts. But when it is needed, we'll go to that. Okay. Hard hat plugin Null has several features distinguishing it from Ethereum, which means that Hard hat is not natively compatible with cluster. Yeah, and that's why also I think you can't use Foundry. Uh, yeah, that's why there is no mention of Foundry. When I was going through the documentation before, they were talking about found. There was no Foundry. I didn't know the reason, but now I do. However, it is possible to use Hardhat with nil by installing nil Hardhat plugin. This plugin ensures compatibility between the convenience and familiarity of Hardhat and unique architecture of nil. The plugin uses Ignition and Ethers to handle contract deployment and interaction with cluster. It is also possible to use other combinations of packages such as Ignition and EVM to extend hardhat nil hardhat plugin. Note that use of these additional packages may cause instability in how plugin operates. Block Explorer, cool. Let's go to nil 101. Setting up CLI, new wallet, deployment of the contract. There is a simple contract that they created. Sol C, okay. Why they're using Sol C? I don't understand. Can't they just use hardhat to compile? Deployment command is also different. Wallet deploy path counter dot pen salt expected output contract address. Also, we need to install Solc. Is that it? Because there was no mention of it at the start, right? When we were going through overview and prerequisites, they only said no node, hard hat, get, and something else. There was no requirement for Solc. Call increment function counter.avi call read only. Okay, let's go through each of them and just start with installing the CLI. Let's copy this, go back to our project. Okay, nil dash dash version. What? Oh, it's just nil dash version. Nil version 0.1.0. We can check it near nil CLI. We can go to this repo, but I don't see. We ran the same command, right? Yeah, install sh. GitHub repo this local this kind of name is given. Isn't that simple one? Yeah, I know this is skill issue, but okay, we have installed it. Nil 101. Now we can do the skill nil keygen. Keygen, let's go. Excellent. I didn't know this will happen. Okay, I'm not going to use that. That's for sure. Then there is this RP, nil config set RPC endpoint. That's one command. Let me switch back and I'll set. I'm gonna set it to my RPC that I got from the bot, the token bot I said that I said. Okay, we have done this. Create a new wallet. Nil a wallet is just a smart contract that can handle payments. There are no other structural differences between a wallet and a smart contract, which means that a wallet can support any logic that can be expressed inside a smart contract. Yeah, I already said that. Uh, I want to actually see the implementation. That's more interesting. Okay, let's go back and say wallet new and see what happens. Not sure what will happen. So, okay, excellent. We created a new wallet. Okay, there is one more thing. Expected response, we didn't get that. We just got new wallet address. Maybe they have updated the CLI and documentation is not updated. That's the reason. That's why we are getting different outputs. But okay, we can see this nil contract code and then the wallet address. Nil contract code, wallet address is just a byte code. Okay, so we can get the bytecode. Nil wallet top up 100,000. 123 123 top up, and we'll wait and see what happens. And we can see next command is wallet info. We get the wallet and we get the public key. We already have seen this our wallet. This is the public key for that. Then there is advanced tutorial creating wallet. Okay, we'll take a look at this afterwards. Deploying a contract. In nil, contracts can be deployed on different execution shards that act as separate blockchains. Contracts can communicate with contracts on other shards, avoiding state fragmentation. Any smart contract deployed on Ethereum compatible network and written in Solidity can be redeployed on nil. Okay, there is a caveat, right? Because uh, I have seen a page in the nil documentation where they talk about the opcodes that are supported and opcodes that are not supported, or they just show like opcode that are not supported. So if your contract is using one of those opcodes, you have to change your contract. So just keep that in mind. And also you have to write all the tests if you are using Foundry to hard hat, so that yeah, just to test everything works with nil. That's the only thing. So keep that in mind. This statement is correct, but there is a caveat. Now counter. Okay, we have this compile. Okay, we can paste the endpoint here. We can regenerate the account. We can deploy everything here. Oh, cool. That's pretty cool. Let's see in our. No, we don't have Sol C installed here. Let's just say Sol C install Ethereum. Installing Solidity. Till now, I haven't used, I haven't installed Sol C because I was just using like Hard Hat or Foundry, whatever there is. This is the first time that I need to install this. Okay, let's go back. npm install solc-g. No, sorry. It just installs that. Okay, let's run these commands one by one. I'm just on. If you don't know, I'm on Solidity documentation, so you can just Google that. Okay, it'll update everything. Next, sudo apt get update sudo apt get install solc. Now we'll have the solc part. Okay, do we have? Yes, we do have solc. Let's go back to browser. Nil. We can copy this file. Do the. We can execute this afterwards. Let's create a new file. Counter.sol. But spdx license identifier is not there. pragma MIT. What else? What is this? Hash auth data. Okay. We sorry. We removed all the warnings. Now next part is this. Sol C path to counter is just dot slash and dot slash. Yeah, it created a new ben file. Next, this wallet deploy nil wallet deploy dot slash counter slash counter dot ben. And for salt, I don't know if that's salt is salt, right? We can just keep that string. If we get the error, we will change it. Yeah, I thought so. Deploy dash dash help, and then we'll see what salt needs. UN 256. So any number, let's say 2025. Oh, any number works. Great. You see this? Let's go back to browser and we got the transaction hash. So that was the message hash and then the contract address. We got both. We can interact with it. Nil wallets, nil wallet, send message, contract address, increment, and then the ABI. Okay, copy that. Let's go here. No, paste. What happened? What's happening? Okay, I'm just changing the address. I'm just putting the address and let's run it. Path. I need to change the path to counter. There is no ABI file. How? When we ran the other command, oh, there was no ABI file. Dash dash A ABI. Okay, now we have it. And we should get something. We got the message hash. We why did we get that message hash? Oh, sorry. Message hash in it is transaction hash. So keep that in mind. We incremented the counter and we got the message back. So hash of the transaction back. Now we can get the contract counter data. Like what is the count? We'll get the count basically. We can change this to change the name of the function get value, and command which is call read only. Counter 1. Okay, we increased it once. Let's increase it again. We should get the message hash. Then let's read it too. Cool. It is working as expected. Okay, also the time is over, so we'll complete this tomorrow. And this nil series will take few weeks, at least a week to complete, because there is a lot more content here. That's why. Yeah, okay. I hope you liked today's stream, uh, about nil and zk shards. Zk sharded EVM. It wasn't. We haven't dived deep on it, but tomorrow we'll continue reading about it and just going through the documentation. Okay, cool. Have a nice day then. That's the stream. Have a nice day. Bye. Also, don't forget to subscribe if